share our screen. And here we go. Well, I hadn't opened the PowerPoint yet. That would be helpful. Go back and try to share that screen again. I need to exit that, try again. There it is. Okay, so this is chapter 9. We have basically covered this already in lab. So that's why it makes this very light lecture. It makes it very easy. It's very short. So it is definitely, as we say, a softball for you. So this is one unit that you should just knock out the questions when they come up from chapter 9, because you've already accomplished the details of this chapter. You've already mastered in lab, right? Pipetting, dilutions, okay? And then we have a couple more terms to cover. But that sets us up because we got fun starting Monday. Monday, we're breaking out our ELISA workshop is what we call it. So we'll be doing it all week. So it's going to take us a little bit to prep for the lab, and I don't know if I think I like you guys to prep it because it's pipetting and diluting and rehydrating and doing a lot of that, and that's practice. And then if we don't get to the actual experiment on Monday, then we'll do the actual stuff on Wednesday. But it's an ELISA workshop, which is you're going to do an ELISA looking for an antigen or looking for an antibody. We're going to probably do the antigen first because that's kind of like the COVID thing right now. Everybody's searching for the antigen, and then we'll flip it over and do the same. We got enough stuff with one kit that we'll do it again for antibody detection and work that angle too. So this is a fun kit that I've done for years, and it's really useful. It shows it to you. You get to practice it, and it works. I mean, I know some of y'all on micro are about ready to throw things at me, but ELISA works very easily, and it's a very proven experiment that I like to do, and it's very, very simple. It's not hard to understand what you're doing, but it's a cookbook, you know, step by step what you would do for any testing like this. So we'll probably flip the schedule. So we got 10 next on Monday, and we're probably going to skip over and pick up the chapter that has ELISA in it on Monday. So you'll have a lecture over that, and we'll go back to 10. I almost put 10 in today, but I was like, I'm just pushing it, and you know, it's Friday, and I had it scheduled to do this one, but we'll do that switch for Monday, so you'll have the ELISA lecture before you walk in on Monday to do the lab, and then we'll come back to 10 on Wednesday, and then we'll keep moving forward as we go. So blood specimen prep and measuring, simple dilutions, compound dilutions, and testing parameters. Like I said, this is a review for you. But this is a definition that, you know, we put it in the course title, serology, and that's kind of where we're headed now, because we've kind of moved from immunology. You know, I said that first section, that first unit, first 2 units were going to be immunology. That's the antigen, the antibody, the principles, the interleukins, the T cells. I'm gonna light y'all up. I saw something today. Sorry. I was gonna do it at first, but I was gonna make sure. Hold on. Okay. I'm gonna stop the share just a second. I wanna do this right quick. If I can get to it. Hold on. It's on Facebook. See, I think you'll appreciate it because y'all look like y'all were spent after that lecture today. Okay, let's see. Look at this. Hope I can blow it up some. Come on, can you get to that picture?
It's downloading.
Oh, it is?
I think, like, click at the bottom of the screen.
Down here?
Yeah, maybe.
No, let me just save it.
Full size, maybe under, like, Yeah, where you're at. No, go back over to the little label by.
Oh yeah, beautiful. There we go. Oh yeah, look at that. This was posted. I was going to Facebook. This popped up on Facebook. This is from the Louisiana Lab Society on their Facebook page. And I thought, well, when I listened in on your lecture earlier, I was like, I need to post this so we can really have a nice poster to put in your room. All right? Don't you want to put this up? Oh, I need to share it with.
Being honest.
I need to share it with Zoom. Hold on, Zoom. Hang on just a second. I need to share this screen with you so you get the full effect of it. There you go. Did y'all go over this today?
Miss Carter with that on the front.
Did y'all go over this? Where were you? Y'all were in erythrocyte, right? Right over here.
Yeah.
Y'all were here at EPO. I know y'all, I heard EPO in the lecture. But did y'all go over your granulocyte, monocyte, colony stimulating, and your IL-3s and IL-3? Did y'all go over that? Did you get the interleukins in there?
No.
See?
We talked about erythropoiesis.
Well, that's here too. Yeah, but there was a whole bunch of interleukin work before you get down there.
Yeah, no.
All right, look at all that. Look at all those IL-3s, IL-5s, right? Colony stimulating. Yeah. Isn't that fun? Look at all that influence that our immune system has over the hematopoietic stem cell. All right. So I know that might be a gift. You know, I give everybody, print that off and get that to you.
Can you print it off in color?
Yeah, we got a color printer downstairs. Just don't tell Dr. Walls I'm printing in color. All right. So I knew y'all would appreciate it when I saw that posted today. I was like, yes, that's exactly what they're learning in the two classes this semester, right? All right, when you combine the two, combine hematology and immunology, this should just roll off, right? You got all this info. All right, so we're gonna stop the share. And we'll share back to the PowerPoint. Sorry, it's not as exciting as that wonderful picture we just had. All right, so back to serology. Serology is the study of fluid components in the blood, especially the antibodies. Okay, so immunology, study of the immune system, and then serology kind of gets boxed into the lab where we do the testing. So when we do antigen antibody testing, that kind of gets called serology because we're using serum, all right, to do those tests. And those are the components that are in the fluid component of the blood. The serum, of course, just the liquid portion of the blood minus the coagulation factors. Most frequently encountered in immunological testing, separated from other components of the blood by centrifuging. Y'all all know that. And then, of course, we always like to throw in what is plasma here, right? What is plasma? That is blood that has used up the coagulation factors and clotted. Before it clots, sorry. Plasma hasn't clotted, serum has. Good?
So that's the difference.
The difference, yes, is where it's the same stuff. It's the liquid portion
Look,
of the
I knew
blood.
that, but you said it way more simple than what I've heard it.
Oh, well, it's that simple. If you got a blood tube and it clots and you spin it, that's serum. You got a blood tube that doesn't clot and you spin it, that's plasma. Okay, that's easy enough. It's the liquid portion you're gonna pull off both times. But a lot of times everybody uses those names, just kind of throws them interchangeably out there. Oh, use serum or plasma, and you're like, well, where did I get those? And it's based on how you prep your sample. So our purple top, right, is plasma. Spin it, you get plasma. Blue top, like blue top, spin it, you get plasma. That's why we do coagulation on light blue top, because they hadn't been used up yet. Okay, red top, serum. All right, tiger top, white top, name them, and you got some more, right? Green, plasma, all right? So a lot of times when we first started in chemistry testing, we couldn't use plasma. We had to use serum, right? Still some tests prefer one or the other. So when we open up our book and we go through some of our testing we're gonna do this semester, you're gonna flip it up and it's gonna say, please use serum, please use plasma. So it is a variation there, but you want to make sure you got it. But it's simple. Don't make it any harder. It's either, this comes from clot, doesn't come from clot. Ideally, use fresh serum that has not been heated, right? Because heating will do what? It will dismantle some of the things we're looking for, right? A lot of things are heat labile. For certain tests, complement may need to be inactivated. You just learned about complement. You know it now, right? All those proteins running around. It may interfere with our testing, so we need to inactivate complement. So we heat it up to 56 for 30 minutes. So we might have to prep for that, just to get some of the stuff inactivated. So works both ways. We know that if we're gonna test something, right, refrigerate it, right? And a lot of times we'll prep for send outs. That's what we call them. I don't know if you are familiar with that term. But it's tests that we can't do in-house. So we can't do it inside the lab, so we prep the sample. It gets picked up by Quest. It gets picked up by AEL couriers that run around town in their little cars. I know you've seen the Quest car with the green. You've seen the AEL with the DNA on theirs, you know, and they take them to Memphis or they take them to the airport and send them on, right? They're gone. So a lot of times we have to know, we'll have to check and be sure, and it'll take you a while. I mean, even today, I would still open up the book to see if it's room temp, ambient air, or if it is refrigerated. All right. So some things have to be kept in the fridge. Some things need to be frozen. So we'll freeze some samples before we send them. So the couriers know that there's a box in the freezer for them to check. There's a box in room temperature for them to check. There's a box in micro for them to check, and there's a box in the fridge for them to check. So they come through your lab and they go through all that, looking for those spots, the samples. And it always concerns me because most of the time, all they do is throw them in a little cooler box and walk out. And you're like, well, like, what's going to happen to my frozen sample? Is it going to thaw before you get it to the airport? Right? And they'll always tell you, no, in the car, I've got the right stuff. I just bring in a bag for pickup. But then when I get to the car, I change it out. Never follow them to the car to make sure that's what they're doing. So we put a lot of faith in the courier as they take off with them. All right, so pipetting, you've done that. Volumetric, that's what you're going to be using mainly in chemistry. Chemistry coming up, or you've already had chemistry. Anytime you make up a standard or you make up a control, you need to use a volumetric pipette that delivers the exact amount of fluid they're asking for. If they're asking for 2 mils of deionized water, you definitely want to use a volumetric pipette. Okay. To me, they help you not over, we don't know if we blow out at the end or don't blow out at the end, the volumetric falls, gravity falls down, and it will stop and leave stuff in it. But it's delivered the amount that it says, 2 mils, 5 mils, 10 mils. Graduated, of course, you've done that, whether it's serological, blowout. It's blowout if it has the grid down to the bottom. It's not blowout. You need to get more in it to start, and then you deliver 1, 2, 3. Don't get to the end, those kind of things. And then our micro pipettes, which everybody seems to be more attracted to because it's, set it to a number and you got the tip and you load it up and you deliver that 1,000 microliters for the 1 mil, and you do that 5 times instead of getting a 5 mil pipette. Things like that, because those are nicer, they're handier, and we like those, right? I like doing that. And it's a little more clean and neat when you do a micro pipette. There was another slide that had you doing the finger control, and I just deleted it, okay? I know you'll do finger control in chemistry, and that's fine, but we have tools that allow us not to have to do the finger anymore. We watched a video with a couple of the research students we had in 2nd year, and they put the pipette on this plugged in little up and down. I think it's in the book, shows a picture of it, up, down, right? Got 2 buttons on it, it's battery operated, and it hooks a pipette in there. It's much easier than trying to get your finger under the bulb and get it over there before it drops out, and right. Anyway, don't, when Dr. Folsom gets going, y'all are gonna say, Mr. Rector says, she's gonna say, are you telling my students they don't need to do fingers? Yeah,
We use mostly the micro.
thank, good. Here's the meniscus, that's at low, because we get this, you know, pull up to the side to make a smiley face, right? So we know that we always measure something to the bottom of the meniscus, and that's old school, that's junior high, that's high school. You should be very familiar with the meniscus and measuring all up to that level. Y'all are experts in dilutions, right? And we've had 3 problem sets. You've run everything from molar to percent to serial. This is all review. I mean, this, I'm not even gonna spend, this is just like, we'll just go over definitions, but you've done these. And we're gonna do more of these. So you'll get some more dilutions to do. Not problem sets, but actual like experiment stuff. But really what we wanna do is just, it'll say, okay, if it's a real high level, like we'll measure something, it says, oh, it's, you know, real high, then we have to dilute it. But for the most part, we're doing some of our reactions to look at a serial dilution for antibody detection, antigen detection. Y'all did that one day, and we adjusted, right? We finally figured out that AB antigen is a little stronger than just a regular antigen, so we needed to dilute it a lot more. So, but you saw the reactions, and that was the main thing. The solute is the material being diluted. These are just definitions. Diluent is the medium making up the rest of the solution. So we have solution as both together. That's the definition. And then we have solute and solvent, if you want to think of that as the diluent. Relationship between the two is expressed as a ratio or fraction. And we have equations for total volume of solution, the amount of solute, the amount of diluent needed. So we've worked those problems. You have definitely some examples on those. So 1 over the dilution is the amount of solute over the total volume. That's where I want you. It's this top one, total volume. We played with that through every problem set. Here's our serial dilution. Compound dilutions, you know, going from 1 to 2, splitting in half to 1 to 4, 1 to 8. Right, you are very familiar with that. We did 3 problems with this one, and then you actually did the tubes themselves. A nice serial dilution. So I'll ask you this: which one of these, right? Let's just look at the colors, right? So in principles, remember back when you took principles? Was there anything about the spec, or are we waiting on chemistry for the spec? Did you answer that? Chemistry? Okay.
Yeah.
So we're gonna pick on Heather today. Anybody else been in chemistry already?
Yeah, we did that.
Tristan, you're online. Okay. So here, right, this is basically what we're doing, right? You see that, and the spec, which is how the chemistry machine measures, right, with a light source. So we're shining a light through the sample. And these reactions, we have reactions with color. Then we have reactions with, say, NADH that doesn't leave a color. But the light that shines through there is infrared on the other side, in spectrophotometry, all right, for absorbance, all right? So the darker that solution, the less light gets through, right? So it absorbs the light more because it's dark, like shining the light. It's not going to get through. So this, being darker, right, has more absorbance but less transmittance. And that's right, you know, transmittance is how much light got through, absorbance is how much light stopped. And that's how we measure. So the change in the measurement is based on the dark absorbance of the light. So our chemistry analyzers, that's how it works. I mean, your reaction goes into a cuvette or a test tube, and that spectrophotometry at a certain nanometer throws that light through it, and then whatever gets to the other side is measured. So you'll see that absorbance is going to decrease as we dilute. Okay, so it goes out here, more light's gonna get through, so the amount percent transmittance is gonna increase as we go. So they're inverse to each other.
I think I even did that in Gen 1 and 2.
Yeah, that's what I
Yeah,
was
we
talking
did that
about.
for Gen Chem
They
too.
did
Good.
it in clinical chemistry too
Okay.
for the program, but
I didn't know if I'd ever do that in real life.
Yes. Yes. You're gonna do a lot of it in real life. All right. Basically, this is how you would set up. I think we've got the idea. It is tough though when you think about how you get a certain dilution done. And I've spent a little time. I think we talked about it in class a little bit, but we think about again the chemistry is what do we do when we have a high level of a detection? Let's say we take the simple glucose, right? Because we love glucose, and you're going to do glucose on everybody. And you're going to see a glucose sometimes run up to the highest level of detection. And what I mean by that is that we have a reference range in chemistry where we say that the reference range for testing, now this is not reference range for the patient. This is a testing reference, which means we can't go from 0. Okay, 0 is not where we go with chemistry, even though a lot of people, if it reads 0 on the machine, will report 0. There's going to be a minimum detection. So there's going to be a less than for the minimum, like less than 0.01 cannot be detected. We can detect 0.01. In all sense, it is 0, okay? But then there's going to be a level at the top of that range that we can't detect over accurately. So we look at what's known as a straight line, okay, for a standard curve, straight line. And we have standards that we run to point that line in where we want it. And then the patient just lands somewhere around that.
we did so many of those.
We did so many of those. And all of a sudden the patient lands out here, away from where the line's straight. Because once the line gets here, it starts to curve. And the patient ends up here. That's not an accurate reading. So you might get a glucose of say 700. Well, your detection range might be 600. So anything over 600, you got to dilute it back down into the range. And we've talked about this, I think, once. But when we say, hey, you need to figure out how much you need to dilute something, that means we need to put it into this range somewhere. So if we got a glucose that reads 700 on the analyzer, but our range was, and it'll tell you assay range, it's a little warning that says out on the printout. Some people ignore that and just go 700 dot, right? And we don't want you to do that. We want you to take that 700, get it back into the range. We got to dilute it. So we say 1 to 2 dilution, right? Cut it in half. Makes sense? And if you had 700, you could definitely do that. 700 cut in half is 350, and that's in our range. So you would dilute your sample. So sometimes we can use deionized water, and sometimes we have to use diluent that's in them for the machine. Make sure you know which one. Make sure. Okay, so I know that's Dr. Folsom teaches that you got to look up the procedure to see where the dilution needs to be done. It'll say use deionized water. So you just take your serum or your plasma and you dilute it 1 to 2, 1 part, 1 part. Make sure you get enough that the machine can read. Okay, don't do a 10 microliter, and then put it in the cup and go, why didn't it pick it up? Right? Why didn't it read it? Because it needs at least a half mil to read. You didn't put it in there. You didn't give it a half mil. You didn't give it 500 microliters. But if you know 500 microliters, you do 250, 250. And then you get a 350 reading. The machine will automatically calculate it. It'll times it by 2. And then it'll say 700 or 750 or 780. But it'll be more accurate that way than you just saying, no, it got out here on the outside of the reference range and we just said, go with it, right? Because it printed it. It said it was 700. Okay. So a little bit diving into the dilutions for chemistry. The titer, okay? We went over this. We did an antibody titer in lab. When was that? Monday? What, Monday? Monday? No? Last Monday? I think it was last Monday, then we didn't have lab Wednesday. Didn't we do the titer on Monday? You remember? Or was it the week before?
I think it was the week before.
Okay, week before, I'll go with the week
This
before.
Monday we studied, we
Yeah, we
did
did.
Oh, we
those
did
case
those,
studies.
we did the case studies and
Yeah.
Preston wanted me to post those and I didn't, I forgot,
Yeah.
sorry. Alright, I'll do better next time.
Alright,
Sure they get
I'll
posted.
forgive you this time.
Okay, thanks. The last two in which a positive reaction is visible. And for most of y'all, it was all the way to 12, right? 12, it was greater than 12 because you never got to a 2 that it wasn't reacting, but we finally did. The third lab finally got it. Finally, but it was still out to 10 or 11. I mean, it's still strong reaction. But that's what? An indication of the antibody strength. And we used an AB antibody and they are strong, okay? And the reason they're strong is because the antigen on the cells that we used is strong. So that is a definitely strong agglutination. We've already made notes. We're gonna make sure we use the D antigen next time because D antigen is a lot weaker than A and B, but you're gonna learn that next semester, okay? But we did this, we've already completed this. Sensitivity. Sensitivity, we hear that a lot, right? Right now we're hearing that COVID test is not very sensitive. It's just picking it up, but how sensitive is it? Are we missing some positives? Are we calling false positives? Are we calling false negatives? What are we actually doing with our test, right? So sensitivity is very easy to calculate, real easy, right? We have true positives. O divided by the true positives plus the false negatives. So how would that work with COVID? I'll give you a minute to think about it. So we got this new COVID-19 Abbott antigen testing machine. 15 minutes, right? The governor wanted that. We're testing people in 15 minutes. They know if they're antigen positive or antigen negative. But they're saying, the health department, Dr. Romero is saying, if it's positive, it's positive. So he's saying, you're done. No more testing. You test in 15 minutes, you test positive for the antigen, we're calling you positive. But if you test negative for the antigen, we're sending you on over to the PCR testing line, and we're gonna send your swab to do PCR on it. And then we'll know how many false negatives we got. Okay, so when they say sensitivity of the test, what they're doing is following up with this COVID-19 Abbott ID Now thing that got put out, right? We're still trying to get one here. We got a couple on campus, but I was hoping by now I'd hear from somebody and I'd be able to get one. But we're actually, in that same one, we're actually going with trying to get the little card. They've actually gone even better. You don't even need the machine anymore. They're gonna do a little, just like a flu test, right? You got a little card you're gonna load with the swabby stuff, and then it's gonna run across a little strip, and when the antigen's there, it's gonna light up. We're gonna say, yay, right? Just like a pregnancy test, just like strep test. We're gonna be there soon. I've seen them, but I'm trying to get some. I got Miss Carly working on trying to find me a box of those, and we'll bring them in. We'll do them if we can get one. They're not just outrageously high. When it's outrageously high, yeah, that's the way we do it in lab. It'd be an unofficial, but we
I have
definitely
a
do.
question, looking at the app, and how do you know if you have the COVID? Like,
What app?
the blood donor app.
When did
Oh,
you
it'll
go
tell
there?
you. Your results will post.
It'll take a couple days.
Well, it already said, I've only ever donated 2 units, this was my 3rd unit, and that's popped up already. So will it
Okay.
just say that I have it on
It'll
there?
say positive or negative.
It didn't say
There's a
either.
label that says COVID antibody test,
You click
and you
on it.
click on it, and it'll say positive or negative. It's a one like.
But they hadn't done it forever. They've only just started doing it.
Yeah, I just donated Sunday.
They hadn't got the result yet.
They
It's
have,
close.
I put
It's close. Let me
3
see.
units.
Let me see your app. Usually it's on your profile.
'Cause I was really wanting to know.
Yeah,
That's like the whole reason I donated.
Yeah.
Usually it'll come up right here, but let me look. It says, where's your COVID?
Mine's right here, so it says COVID-19 antibody test. When I clicked on it, it says negative.
Yeah, where?
Yeah, it was right here in the top. There's an update. on the
Voucher
app.
donation,
Let me see if I need to update it.
Maybe.
Weird.
blood donor, power red, platelets, plasma. No donation so far. I don't see it yet. I don't see it yet. Good blood journey.
9 people.
Okay, sorry, it usually
No,
it
you're
comes up.
fine.
All right, so let's go back and see how we do this COVID testing. So true positives, right? So COVID test, get an antigen test, well, it's gonna end right there, right? So we gotta call true positive, is gonna be that positive test with the antigen. Are we gonna verify all those? We need to. Abbott should have, right? But a lot of people were doing like an emergency FDA approved testing, and they weren't really they're just gonna collect the info kind of on the fly. But here's where we would get the true positives plus false negatives, which would be, hey, you tested negative with the antigen test, but when we sent your swab to PCR, it came back positive. That's a false negative, okay? So if sensitivity is not 99%, okay, then you're getting a lot of false negatives, okay? It's increasing your percent, or decreasing your sensitivity. Okay, so you're missing. It's not a very sensitive test. It's not picking it up like it should. Because it's there with PCR testing. The virus antigens are there, okay, but it's not picking them up. So it's not a very good test. So always look for this sensitivity on the test. Make sure it's in the, closest to 100 as you can get it for sensitivity. Okay, some people were reporting back 60% at the beginning when COVID, that test came out. And that's just like missing half the patients, right? Specificity, portion of the people who do not have a disease or condition who have negative tests. Oh, we gotta do it. Sensitivity is proportion of people who have a disease or condition and who have a positive test. So it indicates how small an amount can be measured and still produce a positive test result. So is it sensitive? Is it a very good sense? Is it a sensitive test? Specificity is the portion of people who do not have a disease or condition who have a negative test. So that's a key definition as far as specificity versus sensitivity, okay? So it's the true negatives here divided by the true negatives plus the false positives. How would you know if it was a false positive? That would be send that PCR test still off, even on the positive antigen test. Go ahead and send it to be verified. Okay? They're not doing that. So we're not getting what? Specificity. We're only getting sensitivity results back. Positive predictive value, the probability that a person with a positive screening test actually has the disease. We take our true positives and we divide it by the true positives plus the false positives. Okay, so that is our predictive value that if you have the disease, you'll test positive with the test. Okay, so all of these are used. If you go to work for Abbott, which a lot of our graduates, can. We have one working at Beckman Coulter right now, a recent grad. But you can't. I mean, you can go to work for these and be in the testing, just developing tests. There was a test, I saw a testing system, a company up in Rogers was putting out a blood test in a little self-contained testing unit that they had gotten, but they couldn't get American approval. They had approval in Europe. They didn't have approval here. I never have heard if they got approval, but it's a little startup company in Rogers, Arkansas that's doing lab testing, probably employs 5 people. But that could be you one day. I mean, if you take this serious and want to do something like that, could be you. So keep that in mind too, because it's not always hospital, clinic, you can definitely take your knowledge and go forward with it. A negative predictive value, the probability that a person with a negative screening test does not have the disease. So just you do true negatives divided by true negatives plus false negatives, and you come up with your negative predictive value. Those are definitely some test parameters we need to put in our memory bank. We need to make sure we can understand those. And that is our lecture today. Any questions? Like I said, it's really light. It wasn't a whole lot, but there were some important things in there. Got it. But a lot of stuff we've already accomplished in lab, and then we'll continue on Monday, Wednesday, Friday next week. So have a great weekend.
I really haven't talked about clinical chemistry since I took it until now.
So
But,
we're gonna stop the share, say bye-bye to Zoom land. Y'all have any questions? Okay, I'll take that as a no.
no.